question set number 11 here from yesterday. It says the following diagram shows 2 point sources and selected field lines. And then it talks about the solid field lines result from determining the direction of the net electric force on a test charge placed at a point in the line. So this is a force thing, whereas the force on a test charge placed at a point in the line, that's field, right? That's how we define the electric field, is a region in which there would be a force acting on a particle if there was a particle there. Now these dashed lines might not be quite as familiar with that. Don't panic about that, all right? It says the field lines represent or result from connecting those points on a line that have the same electric potential when a test charge is placed at that point. We haven't done anything with that. The question, what's the question say? The field represented by solid lines is classified as a vector field or a scalar field? How do you know? Because it curves? Not so much because it curves, no? We get arrows. We got arrows on it, right? There's a direction associated with it. Whereas the field represented by the dotted lines are vector scalar. Scalar. There's no arrows on the end of it, right? We don't even have to know what this is. We don't need to know what this is. We don't. It's not part of Physics 30. Okay, this is a test not of what is this dash field line that is equal electric potential. So that's not what it's testing. It's testing, do you know what a vector is and what a scalar is? A vector has direction, a scalar has no direction associated with it. That's all it's testing there. So the answer for this question ends up being A, a vector field and a scalar field. Numeric response number 1, the electric field strength, this distance from this point charge is what? We're going to circle the centimeters here. And then we're just going to find the value of the field using the producer equation. This is a non-uniform field, so we're back to that first producer equation, not parallel plates, nothing like that. We get the value of K, we get the value of Q, and make sure you make the value of R in meters, 0.040 meters. When you do that, you get a value of 6.74 times 10 to the 7, which means the answer for this is 6747. Now, if this was a B times 10 to the W, a B times 10 to the W one, our answer for this one would be 6.74. Make sense the difference here? A decimal B C times 10 to the D is 6747. B times 10 to the W is 6.74. Next question, we get 2 bumper cars colliding with each other. Man, it looks like there should be like a conservation of momentum question with this, eh? Well, there was actually. When this appeared on an exam, there was a conservation of momentum question with this. In fact, I think we've already done it. I think we have. I just separated them because, of course, the two don't go together when we're working through the topics one by one. We want to find the electric field between the top and the bottom of this, the top grid, the top plate and the bottom plate here. This is clearly a uniform electric field, so all we're going to do for that is to say delta V over delta D, the potential difference divided by the distance. That's going to be 120 volts divided by 4.0 meters. That's going to give us 30 volts per meter, or they give it in newtons per coulomb, right? Volts per meter, newtons per coulomb, doesn't matter. Now, is it up or down? How do you know whether it's up or down? Field line always points away from the positive and toward the, so it's going to be down, right? Field is going to be 30 newtons per coulomb down, so the answer for that one is B. 3. Pair of parallel plates is separated by a distance of 1 centimeter, connected to a 12-volt battery. Magnitude of the electric field is E. The second pair of parallel plates, separated by a distance of 3 centimeters, connected by a 6-volt battery. Which of the following equations describes E2 in terms of E1? What I would do for this one is kind of a variable value changing type thing. It's not the only way to do it, but that's the way that I would do it. I would say that E1 is equal to delta V over delta D. And then I'm going to say E2 is equal to, well, delta V is a half of what it was, right? It was 12 volts, now it's 6 volts. So we're going to say it's a half of delta V. Delta D, well, it was 1 centimeter, now it's 3 centimeters. A half divided by a third is a sixth. Whoops, that's not what I wanted to do. That's not what I wanted to do. Delta D was, what was delta D? 1, now it's 3, so it's 3 times delta D. So my number was right. Okay, my number was right. I just expressed it wrong there. 3 times delta D. Half divided by 3 is a sixth times delta V over delta D. And look, we know the value of delta V over delta D. It's E1. So let's just say it's a sixth of E1. So E2 in terms of E1 is 1/6 of E1. The answer is D for that one. 4, good question here, number 4. We got two charges here. You got a positive charge plus Q and a negative charge minus 16Q. So clearly the second one has a lot more charge than the first one. We want to find a point here, anywhere along here, that has a net electric field of 0. In other words, the field caused by A has to cancel the field caused by B. We know that it cannot be position 2 or 3. Okay, it can't be those. Because look, the field caused by A at position 2 is this way. The field caused by B at position 2 is this way, away from the positive toward the negative. There's no way those can cancel each other out because they're in the same direction. Same deal here. I don't care what the values of them are. They can't cancel each other out because they're both in the same direction, away from the positive toward the negative. So it's either got to be 1 or 4. So which one is it? Well, let's look at position 4 first. Okay, we'll look at position 4 first because that's not the right one. We'll justify why it's not the right one. Why is it not the right one? Well, if I look at the field caused by A at position 4, okay, that's going to be pretty small, right? Agree? We got a small charge in a big distance. That's going to be a pretty small field, right? What about the field caused by B? That's going to be very, very large because, well, charge B is much bigger and the distance is much smaller. We got our fields in the right directions here to cancel out, but one of them is clearly going to be a lot bigger than the other one. Okay, let's take a look over here at A. The field caused by A is this way. It's a certain value. The field caused by B here, it's further away, but the charge is more. So making it further away makes the field smaller, but making the charge more makes the field bigger. This is the only possibility of these two canceling out, right? The only possibility of us getting the same field in opposite direction there. So the answer is going to be 1. Okay, the answer is A. Does that make sense? All right, 5. The electric force acting on an alpha particle between these plates. We're going to use our two uniform field equations. Remember we have our top 2 equations in our Venn diagram. We have our bottom 2 equations. We're going to use our bottom 2 equations here. First, we're going to find the electric field strength. E is equal to delta V over delta D. Make sure you make the distance in meters. Get 166.67 either volts per meter or newtons per coulomb. And then we're going to use the experiencer equation, E is equal to F over Q. Okay, we got this. We got this. We solve for F. And when we do that, it works out to be A 5.3 times 10 to the negative 15. Now, here's a graphing question. Potential difference versus plate separation for parallel plates. This graph is not labeled real well. It should be labeled delta D on the bottom and delta V right here. The reason that it's labeled V and D is because this is a really old question. They switched the curriculum about 12 years ago, and prior to them switching, some of the stuff was the same, some of the stuff changed. Okay, this stayed the same, but they changed the equation. They used to say E is equal to V over D, and now they say E is, on the data sheet, E is equal to delta V over delta D. So 12 years ago, people would have been comfortable with V and D. Now it should be delta V and delta D, just to be consistent with our data sheet. So it's potential difference versus the distance. And what are we looking for here? The rate of change of potential difference with respect to the plate separation. Yep. The rate of change of the potential difference with respect to the plate separation. If you're looking for a rate of change of y as compared to x, what are you really looking for? The slope of the graph. So what I would do is pick 2 points on the line, pick 2 points that are far apart on the line, probably this one, because that's the easy one, right? 0, 0. Maybe right here. It's not going to be perfect because it's kind of difficult to see exactly what that is. I'm going to say around 21-ish. 21 minus 0 over 10 minus 0, and it gives us, oh, look at this. What did I miss? Oh, what did I miss? 10 to the negative 2. That should be pretty much the first thing I look at, right? Is our axis of our graph. So we're going to say 20 times 10 to the minus 2 minus 0 over 10 times 10 to the minus 3 minus 0, and that gives us, sure, that should be 21. That gives us a value of 21, actually. 21. So the answer for that one is going to be D. Now we want the units for the slope. The units for the slope should be pretty easy. We've got y-axis is volts, x-axis is meters. The units are going to be volts per meter. The answer is B.
What does SI stand for?
SI just stands for System International, the metric system, basically. So it's the units that we use. It's meters rather than feet. It's kilograms rather than pounds. Yeah. Actually, not quite. It's newtons rather than pounds. Pounds is actually not a measure of mass. Pounds is a measure of force, which corresponds to newtons rather than kilograms. But that's the idea, at least. Okay, 8. The physical quantity that the slope can represent is the what? What's the physical quantity that the slope can represent? We got to do our little y equals mx plus b thing for this. I've never seen this graph before in our lives, so let's do our y equals mx plus b thing that we've done on a couple of labs now. On the y-axis, we have delta v. M is the, what does M stand for? Slope, yes. M is the, sorry, x is the delta d, and b the y-intercept. Clearly there is no y-intercept that goes through the origin here. Now we got to come up with an equation that appears on our data sheet that has delta v and delta d in it. What equation on our data sheet has delta v and delta d in it that's relevant to this graph here? Yeah? Yeah, E is equal to delta v over delta d. Oops. I don't want a vector sign over that. I want a vector sign over this with the absolute value. Now I want to rearrange this to take the same form. I want to solve for the same variable. Delta v is equal to E times delta d. Now I've got two equations, one from the graph and one from my data sheet. Delta v appears in both, delta d appears in both, and the slope, we're left with the slope on one, and we're left with E, the electric field, on the other. So the slope is going to represent the electric field strength. The answer is going to be C for that one. And finally, number 9, the electric field strength is just sufficient to suspend a proton in the Earth's gravitational field near the Earth's surface is what? Suspend. What does that mean? Suspend. Yeah, there's another word that I can think of that means the same thing as suspend, essentially. Equilibrium. Right, if it's an equilibrium, what does that mean? The forces have got to balance, right? Two forces have got to balance out. So what two forces are going to balance out in this case? The electric field strength sufficient to suspend a proton in the gravitational field. Don't set the fields equal to each other. Don't say E is equal to G. Don't ever set two fields equal to each other. That never works. Rather, set the forces equal to each other. The electric force equal to the gravitational force. Technically, those forces aren't equal. Technically, they're equal and opposite. That's why I put the little absolute value signs around. Okay? If you miss the absolute value signs around, you're probably going to be okay still. Fe is Q times E. That comes from the equation E is equal to F over Q, the experiencer equation, just rearranged. And then Fg, of course, is M times G. We're looking for E, so we're just going to say E is equal to mg over Q. We got M, we got G, and we got Q, and we do the math there, and it works out to be D, 1.02 times 10 to the negative 7 newtons per coulomb.